Not always, for this case only, because X to stress 1 is anti-clockwise. Okay? If let's say point X is on top, it will be clockwise. Does that make sense?
Yeah. Okay.
Okay, so just for this case, it's not always. Okay, do not take it as an absolute, because every element is unique. Does that make sense?
Yes, sir.
Okay, so
Thank you.
don't think that it's always no. Yeah. Okay, so before we go to break, I want to do this example. Okay, we want to. Okay, so now this is our element still, right? Same element. What if now, right? I want to find at a certain plane. Okay, let's say now I want to find a certain plane. Okay, and this plane I want to find is at 30 degrees. Okay, so over here, right? So this plane that I want to find, right? This is the plane I've just drawn. I want to find the plane, the stress on this plane. Okay, so this plane is rotated from the x in a direction that is what? Clockwise. Okay, so I'm going to now call this my direction. I'm going to call this y30. Why y30? Because I started from the point y. I rotate clockwise and y30. Okay, so now where is this on Mohr circle? Okay, so I'll try to copy the Mohr circle. In fact, you know what? We don't need to copy. We can draw on the same circle. So you can see that y30. Okay. So y30 is rotated from point y, right? So now on the element, okay. So y30. Remember what on the element will be what direction? Okay. So from here, let me zoom out. So rather than you get a headache later on, I'll zoom out this way, or I'll go further. Yeah, you can still see this. Okay. So y to y30 is a clockwise rotation. Yes. On the Mohr circle, it's going to be 60 degrees. Okay. So I'm going to from the center of the circle, I'm going to eyeball 60 degrees. Okay. So 60 degrees. Okay. It looks like this. Okay. So 60 degrees. I'm still drawing. Okay. Okay. So where the line I'm constructing now, that is my 60 degrees line. Okay, I repeat again, that is my 60 degrees line that I'm constructing. Yeah, I'm still drawing. Okay, I'm having some technical issue on my end of the computer. Okay, so you all see that line, yes or no? Right, now the 60 is from where? Right, so from y, I'm going to highlight this one. From y, right, it's going to rotate by 60 degrees. Okay, so at this point over here, this is known as your y30, right? At exactly opposite point, that will be your x30. Okay, that will be your x30. So now, how to calculate y30 now? Okay, and so why we want to calculate y30? Because over here at y30, there is two points that we want to determine. Okay, we want to determine our stress y30, normal stress y30, and the shear stress y30, right? And on the other end, okay, on the other end, okay, I want to see is anything. If any of you see the words just shift, just let me know. Okay. At the other end, we have our stress x30 and the shear y30. Okay. So let's try to find these values. Okay, so let's find this. So we are going to find normal stress Y30, normal stress X30, and the shear Y30, and also so the normal stress Y30 and the shear stress X30 are the same. Okay, so I should draw this one as the shear stress X30. Okay, now what I usually like to do is to calculate by the shear stress Y30 first. Okay, so the shear stress Y30 is equal to the shear stress X30, and this will be equal to the radius of the circle, which we calculate to 38.079, right? And then is going to be, we don't know the angle yet. Okay, we don't know the angle yet. My apologies. So the angle we have to calculate now is this angle over here. This angle, I'm going to call it our beta angle. You can see beta, right? So the beta angle okay, is equal to the principal plane 23.2 plus by 60. Okay, so this will be equal to 23.2 plus by 60 is equal to 83.2 degrees. So from here, I will usually like to engage with the normal shear stress Y30 first. Okay, and I'll tell you why later on. So the radius over here is 38.079, and it's going to be sine 83.2 degrees, right? So it's equal to 38.079 times by sine 38 sine 83.2 is equal to 37.8 0.811 megapascal. Okay. So calculate normal. Now, sorry, calculate the shear stress first. Now, the normal stress is equal to, so the normal stress, you need to take the where the center of the circle is. Okay. So you have to take the center of the circle, right? And the center of the circle is not 0. The shear stress is equal to 0 because the shear stress starts from 0. Whereas the normal stress is the center of the circle, right? It's not equal to 0 in a normal stress. It's equal to your average stress, which is equal to minus 5 degrees. And then to find stress Y30 is going to be minus, okay, because it's the left-hand side of the center of the circle. So if you look at over here's our center of a circle, we are going towards the what? We are going towards the left. I've just drawn an arrow and I'm highlighting the arrow down here. Okay. So when that's the case, this will be equal to 38.079. Now it has to be cos. Okay. Because you use sine already, right? Now it has to be cos. That's why I do the shear stress first. Okay. I know it will be different. So from here, the center of the circle is minus 5 minus by 38.07, or I'm going to calculate 38.079. So 38, give me another 2 minutes. Okay, I know you are dying for a break. Cos the 83.2 times by 38.079. So this is equal to minus 4.509. Okay, so this will be equal to minus 9.509 megapascal. Okay, so that is your stress Y30, normal stress Y30, and then your normal stress X30 will be equal to minus 5 plus by 4.509. So this will be equal to minus 0.491. Now, why this is positive? Because if you look at the center of the circle, is going towards the right hand side, right? Which I've just drawn the arrow in highlight in yellow. Okay. So that's how we find the stress state at element Y30. Okay. So go for a break. We come back. We're going to draw the stress state at element rotated 30 degrees clockwise from the original element. Okay. So take a 15 minutes break. We will come back at 10:45. Okay. We will come back at 10:45.